Hello, today you are with Retaj Mohamed, and so today we're going to talk about chemistry. Okay, as we know, chemistry is in everywhere in our life. Okay, it is in our food, in our labs, everywhere. Okay, even in medicines. So today we're going to talk about three main acids that we use every day. Okay, let's begin. First, we're going to begin with the reader's guide. Okay, I will give you a quick scene. Okay, about what we're going to talk about. First, we're going to talk about what is a base. Okay, and what is an acid. These two objects are a main thing in the chemistry. Okay, and we use them a lot. Okay, and how to extract the following acids from fruits and vegetables. And this part is very interesting, I promise. How to prepare them in the laboratory, and how to make a homemade antibacterial soap for the corona these times. Okay. First, of course, you want to know what is a base. Okay. So today I'm going to tell you what is a base specifically. In chemistry, bases are substances that in aqueous solution release an hydroxide ions, are slippery to the touch, can taste bitter if an alkali change the color of indicators. Okay, now of course we tried the pH indicator in our labs. You know when the pH indicator turns blue, what happens? Yes, you're right. When it turns to blue, this acid or this element is base. Okay, base are like NOH. We can find it in metals, earth metals, and alkali metals like NaOH or CaOH2. Now, what is an acid? Okay, this is our next question. An acid is a chemical species that donates protons or hydrogen ions and accepts electrons. Okay, so it accepts or gives electrons. Okay, and an acid also is a proton. Okay, that it donates protons specifically. Here is as I told you, here is the most entertaining part. Okay, these are the types of acid we're going to talk about it today, like the acetic acid, lactic acid, and citric acid. Okay, acetic acid, or as known as CH3COOH. This is its formula. Acetic acid is a synthetic carboxylic acid with antibacterial and antifungal properties. Okay, and lactic acid, or known as C3H6O3. Lactic acid is an organic acid. It has a molecular formula. Okay? And citric acid, or H3C6H5O7. Citric acid is a weak organic acid that has the chemical formula of C6H8O7. Okay? And now let's begin with our first acid, the citric acid. Okay, how to extract citric acid from fruits and vegetables. Okay, let's see how. Citric acid is an organic acid that is most often found in citrus fruits like oranges or lemons or limes. Okay, another type of lemons. And also found in grapefruit and pomegranate. Okay, it has a very high concentration in lemons, as I told you, and here is a picture. There can be as much as 8% of citric acid in the dry weight of a single lemon. Okay, and that is too much of citric acid in one lemon. Now, the second thing is the process of extracting citric acid from lemons. Okay. Before I begin, the first thing you have to make it even in every step you're going to do is to wear gloves and goggles. These are the safety wear for the laboratory, okay? And you must wear it because some acids and elements are kind of poisonous, okay? First thing, as we said, put your safety gloves and goggles, okay? And we will have a 1 lemon, okay? Squeeze it, okay, and put it in a cup. Squeeze the lemon juice and add 1 teaspoon of calcium hydroxide solution to the flask. And now mix it, okay? And now this solution will be calcium hydroxide. Now fill the cup halfway with water and ice and place the cup flask inside. Allow the solution in the cup to get cold approximately 15 minutes, okay? 15 to 20 minutes, it doesn't matter. Now place a piece of a coffee filter over the top of the 5-cup flask. Slowly pour the calcium citrate that is in the 2-cup flask through the filter and into the 5-cup flask. Okay, you will need a coffee filter and filter the cup in another flask. Now, the last step, at step 5, add a 1/4 cup of sulfuric acid solution to the calcium citrate solution that we made. Stir the solution with your teaspoon. Now, this solution that I told you is the citric acid, and how to make it in lab. It's quite easy. And now, how to prepare citric acid in the lab, okay? Citric acid, as we said, is a weak acid, okay? Citric acid is a weak acid that found naturally in citrus fruits like lemons, grapefruits, pomegranate, limes, okay, and oranges. It's sour and tangy flavor. You know when you eat a lemon and you feel so bitter, okay? This is the taste of citric acid, okay? Next time you have to take care of. Along with its neutralizing properties and preservative qualities, make it a popular ingredient in a range of products. And also, you will now you will have to see what includes, okay, food items, beverages, cosmetics, and cleaning agents. All of the cosmetics that you use are having citric acid. This is why you feel, after you get it off your face, you feel like a tangy thing on your face. Now, how to prepare the citric acid in science lab. We will say it in 9 steps, actually. Okay, these are the steps are more than the other one. Now, first thing, we will have to buy citric acid crystalline powder form. It has to be crystalline, not a powdery. It's crystalline, okay? And buy or make distilled water. If you don't know how to make it, you can search on YouTube and write how to make distilled water. You'll find right away what you want. Select non-metallic or non-reactive metal items for the process, okay? You cannot use metallic items or non-reactive items. You will see in the lab like the flask. These things you could use it, okay? It's so safe. Now, step number 4, determine the amount of citric acid powder and water that you require to create the solution. You have to see how much did you want of the citric acid powder and put it in solution. Now, 5th thing, measure the powder, boil the water, the distilled water, or the distilled pure water that you used. Now pour the boiling water over the powder, stirring consistently with a non-metallic spoon until the powder is dissolved. because if you use a metallic spoon or any metallic thing, you will see a large reaction, okay, in it. It may it may dissolve, okay. Now filter the solution, okay. Now that thing allow the solution to cool in room temperature, and now you will be having citric acid but in chemical way in the lab, okay. Now see, this is the citric acid formula, okay. And as we see here, citric acid is made out of 3 carbon and 5 hydrochloric, okay, hydrochloride, sorry, and 1 oxygen and sodium chloride, okay, okay, and equal, or the result is sodium citrate plus carboxylate water, sorry. Now we will be having how to extract acetic acid from the fruits and vegetables. Now we're going to talk about the second acid that we will using today. This is its shape, glacial acetic acid, okay, as you see. How to extract acetic acid from fruits and vegetables, okay. Let's see how. Vinegar, a traditional fermented product, okay, and it can be produced from a variety of raw materials, each resulting in a product with a unique taste and flavor, okay. Acetic acid is identified as a prominent volatile acid, giving a strong aroma or sour flavoring, okay. Thus, it has become widely used as a food preservative and food seasoning. Many seasonings that you use on a salad or food does have the acetic acid. Now, the process of extracting acetic acid from pineapples, okay. Acetic acid is in pineapples with a very large amount. This is why I used the pineapple peels. Pineapple peels we cut the pineapple peels with a knife, okay, small pieces, and the pineapple peels were chopped using a blender with water at a ratio of 1:3 by weight. The filtrate was obtained by passing through the 3 layers of cotton cloth and designated pineapple peel juice. We will filter the pineapple peel juice with a cotton cloth, okay, so we will have only the juice without the other things in the pineapple, okay, without the fibers in the pineapple. And now we will, the media will just adjust it to the appropriate sugar content by adding sucrose at a final concentration of 140 grams per liter. So we will add sucrose, okay, sucrose is a kind of sugar, okay, we will add it at a concentration of 140. Now, to examine the effect of the medium and acetic acid production, diamond phosphate and MgSO4 were supplemented at a final concentration of 2 grams per liter. The initial pH was adjusted by adding NH4OH. The media were then sterilized by autoclaving at 110 Celsius for 10 minutes. Okay, and this is the steps. How to prepare acetic acid in the lab. Acetic acid has been prepared on an industrial scale by air oxidation of acetylide, by oxidation of ethanol. Okay. Here is the formula, okay, or the chemical equation is methanol, which is CH3OH, and CO, which is carbon monoxide. It will give us acetic acid, which is CH3COH. And now, how to extract lactic acid in fruits and vegetables. Cabbage is fermentation of cabbage is a one type of lactic acids in fruits, okay, and vegetables. Cabbage was obtained from a local market, okay, washed thoroughly, and the leaves and cores, and then shredded into small pieces, which is strips, okay, like strips, small strips. Common salt at the rate of 2.5% was evenly sprinkled on the shredded cabbage. Placed in a glass jar and weighed down using a 5 kilogram weight. Okay. Now we'll leave it overnight in a dark place with its water and leave it for 15 days in a 25 or 28 Celsius, which is room temperature actually, and leave it for 15 days in a dark place. And now we will have the fermented cabbage, okay? Now how to prepare lactic acid in lab. Lactic acid is formed by lactic fermentation of sugars. Lactic acid can also be synthesized or in the laboratory. Most of the lactic acid formed in mammals is made by muscle tissue or red blood cells. You know, lactic acid is also in our muscles, okay? This is also a weird thing. I know you didn't know, okay? When oxygen levels decrease, carbohydrate sugars break down into the byproduct lactic acid, okay? In addition, lactic acid can be made for sugars by bacteria or obtained from milk. It also in milk, as you can see here in the picture, or you can find it in some types of bacteria. Okay. As you can see here, these are the lactic acid preparation in lab steps. Okay, I know it's a lot, but this is the real steps. Film first. I have to tell you again. Wear your goggles and gloves and lab coats. Okay. First, fill the test tubes with screw tops with tripartite soy broth. Add 0.15 grams per liter of Brimoxitol purple to each test tube. Take a sterile or toothpick or cotton swab and inoculate each of the test tubes in one with the following. One with scrubbing from your tooth plaque. Use a toothpick to obtain the plaque. One with the yogurt obtaining active cultures. One with a sugar crate. Okay. Make sure you screw the caps on each of the test tubes tightly. Okay. Using your pH paper, take pH measurements of inoculated medium milk for future comparison of data. Measure the pH of all inoculated tubes after incubation period using pH paper. Now determine which test tubes resulting in the lowest pH level. The fermentation of lactic acid from lactic acid producing bacteria resulting in an acidic sour taste. And this is the taste that I told you in the first, the bitter taste or the sour taste that's used in the seasonings, that is the lactic acid. Now this will allow you to further confirm the presence of lactic acid by confirming the presence of lactic acid production in bacteria. Lactic acid bacteria will form small colonies, okay? Very, very small colonies. Test for lactic acid bacteria using hydrogen peroxide. If no bubbles form, lactic acid is formed, okay? Make sure that is no bubbles. If there is bubbles, so the steps are not pretty sure with you. But if you have no bubbles formed, So the lactic acid is made, and congratulations. Now the balance equation of the lactic acid is 3 carbon and 6 hydrogen and 1 oxygen. Okay, 3 oxygen, sorry. So the best part, or the corona part exactly, is how to make the DIY antibacterial soap. So as you know, these days we are suffering from coronavirus and viruses and bacteria everywhere. So we must use a base supplement to our soaps so we could be safe from the coronavirus. And also to wash your hands safe. And now we will begin with the ingredients, okay? As you can see, we will need 5 tablespoons of undilated Dettol, which is base. Dettol has less than 7 pH, which is base. And Pears soap or any other type of soap that you use. We'll need 2 cups of melted soap, okay, which is any kind of brand. Now to the last step in our presentation. How to make the DIY antibacterial soap. First we will begin by adding heat to the soap, okay, on the oven or anywhere. It even can melt with a candle, make sure. Start adding the Dettol on the melting soap. We said that we will use 2 tablespoons to the 2 melted soaps, okay? Add the soap to a soap mold. If you don't have a soap mold, which is, it will be very nice that you will have it, but if you don't have it, you can use ice trays, okay? Ice trays with any shape, like a star or anything, okay? Hearts, anything. And add it to the fridge, okay, or in the freezer, okay, anything, but in the fridge will be better. And now, last thing, congrats, you have an antibacterial homemade soap, which you make sure how you did it, and take care. Okay, last thing, I'd like to thank you for watching, and thank Mr. Sharif and Miss Marwa who will be watching this video. Okay, thank you so much. Miss you.